Hello everyone, welcome to Server Room. We have a very special guest with us today, Ganesh Chellappa. Ganesh has over 18 years of experience in enterprise IT. Today, we'll be primarily talking about large language models. But before we dive into the topic, I just want to talk about what large language models are. Because when I think about large language models, what comes to my mind is ChatGPT. Am I right? Can you elaborate a bit more on large language models?
Yeah, so ChatGPT is probably the most popular large language model, and therefore it's no surprise that that comes to your mind. But the large language models are typically a deep learning engines. They are built based out of a neural network architecture. So there are many large language models out there, and the technology as such is not relatively new. So we can date all the way back to like 1960s, where a lot of educational institutions across US have researched and tried out these deep learning engines. So from a technology perspective, it's not anything new, but what makes it capable is the concept of large language model. So what confines or constitutes something as a large language model is actually debatable, but from a industry standpoint, I would say that the general consensus is that if a model is trained with more than 1 or 1.5 billion parameters, then they are considered as a large language models. But yeah, as a technology, it's been there for a long time, and it has its own benefits. And obviously, ChatGPT made these large language models in the hands of pretty much everybody, in the public. So it is quite popular, and it's something that is still in its evolutionary phase. So we'll see where it goes.
But does Dali come under this or is it completely different?
Yes, Dali is also a form of large language model. So it's the application of it. In how do you use these large language model? What's the purpose of it? So if you take ChatGPT, it's a chat bot that is in the hands of pretty much all the general public now. So you could ask it any questions, and it has been trained on the publicly available World Wide Web data, and so it is quite intuitive, and it is able to provide you with answers quickly. Dali is mainly for image generation.
Yes.
Exactly. So it can be used for generating images. So you could provide it a description, and based on the description, because it's been trained on a huge volume of data sets, it has the capability to generate a completely new picture.
So, also, everyone talks about natural language processing, NLP. And even I've heard a lot about it, and I'm sure our audience would have also heard a lot about it. So, how does these two relate to each other?
So, natural language processing is one of the strengths of these large language models. So, the way these models work is based on a self attestation, or what we call a self realization. So, they have a transformer architecture. So, the idea behind that is you pre-train these models with a huge volume of data sets, and you let the models learn by making mistakes and correcting it, and that's basically what self-realization is. So what it does, and they are very good at token prediction, and because they are very good at token prediction, it directly translates to natural language processing. Say for example, you want to translate a statement like how are you. Let's say you want to translate it into French or Hindi. You will not be able to take every word and literally translate it in Hindi, because it wouldn't make sense. So because these large language models are trained on identifying the patterns and recognize the patterns, it will jumble the words exactly how it should be to convey the same how are you in Hindi or in French in a much more efficient way. So therefore, natural language processing is one of the capabilities and strengths of large language models, but it's not necessarily limited only to natural language processing. Obviously, it makes it easier for the general audience to converse with these LLMs and get valuable insights. But there are many other application areas where you could leverage these large language models.
Even when I first started using ChatGPT and Dali, even I was very much fascinated about how much it can do, because it was almost as similar to Google, but then it had so much information, and it could structure it very well. So I was impressed with that. And even Dali, it could generate a lot of images, and even if we give a silly prompt, it could generate maybe like multiple images. And so it was really good, and it's nice talking to you about that. And Also, moreover, since we are talking about enterprise IT today, so when we talk about large language models, do you have any idea of how we can use this in enterprise IT?
Yeah, sure. But before we touch on that, you mentioned about how you used to Google before. If you have a question or if you want to find out some information, you used to use Google or other search engines, and you said that you found ChatGPT to be like much more user friendly and easy to use, right? So that is true. Google is predominantly a search engine that basically indexes all the websites and information available, and then based on your question, it basically lists those indexes, right? So, in that sense, traditional search engines only take you halfway through the route. It will list you everything, and it's up to you. Say, for example, if you search something and you get the Wikipedia link as the first result, you have to open the Wikipedia link and go through the content and figure out exactly what portion of the content have answers to the question you ask. Whereas ChatGPT is basically trained on entire Wikipedia. So it takes away the requirement for you to actually search that particular page, go to the particular summarized area where you have your answer. ChatGPT can basically just lift that particular answer, even rephrase it if it's required, to put the same answer to you in a much more efficient way. It can do that. And that way, I wouldn't say it's a direct competitor for search engines, but it's definitely the next stage for how people find information. So, in terms of using traditional search engines, obviously these large language models and chatbots are going to be the future in terms of how people, search and consume information. And in the context of enterprise IT, there are many areas where enterprises could leverage these large language models. So, I mean, the most common example would be in software development. Developers could leverage these large language models for code generation or code completion or debugging. I mean, a biggest challenge for developers
It's
generally is
always to
to,
debug,
yeah,
yeah.
is to debug. Like, so you have a code built by somebody 10 years
Yes.
ago, and there's some problem in it, and now you have to debug it,
You
right?
have
So
to read through hundreds of
exactly.
lines to
And
find it.
I mean, sometimes we will forget that it's a code that we wrote many years ago. And sometimes it'll be painful because, like, just like how we evolve and how we get efficient in being a software developer, our code also evolves over time. So when you look at your own code like many years back, then it will be painful, right? So in these areas, LLMs are very good when you use its assistance in debugging a problem. You give the code and you give the exact error message or what is the problem you're facing. As long as you're able to effectively prompt it, you would get the right answer, and it'll make your life much easier as a software developer. Apart from that, there are many other, I would say pretty much every a team or department in an enterprise could leverage large language models. So right next to software development, what comes to my mind is Q&A teams, testing teams, right? So they typically create test cases, which can be a quite cumbersome process. You have to write hundreds of steps one by one and write the expected result, and then you have engineers basically following that. And even for automation testing, you would have to write scripts or even code a little bit in order for you to automate a certain type of testing. In these areas, LLMs can be very helpful because it can reduce the workload. Let's say you have the documentation of how to configure a particular feature or a capability. Now you take that documentation and provide it to a large language model and ask it to create a test case. It would beautifully perform and provide you with the step-by-step instructions on how you can test that capability. So in that area, it's very helpful. Apart from that, you have customer service teams or technical support teams. They could use it for chatbots. Obviously is good, so you can scale your services. But beyond that, it can also be used for creating knowledge bases on problems, like generally that you have to manually create solutions or write templates. You could leverage LLMs for creating or generating knowledge bases. So in that area, it can be very helpful. But anything else, like even legal and compliance teams could use LLMs, to check for errors and optimize and validate their legal documents or agreements and all of it. A business continuity team, even travel and help desk teams can use LLMs. Say, for example, if you were to look for a flight availability or a hotel availability, you would have multiple tabs open. You will probably be searching for it on multiple sites and get that data. But maybe you could leverage LLM. It will, automate the process of travel, hotel booking, accommodation, and all of it. So yeah, I mean, in the context of enterprise, there are various areas where these LLMs can be used. But the technology as such is improving as we speak. It is still in its infancy stage, and the verdict is still not out yet for these LLMs, definitely, in terms of how it can be or it should be used. Governments are building frameworks for how to leverage LLMs and all of it. So we have to wait and watch to see how this space evolves. But there is absolutely no doubt that from a fundamental technology perspective, these large language models are basically for token prediction, right? So it's not for like in-depth functional language or high-level machine language or anything by itself, but it does what it does in a very effective way and efficient way, and that's what gives this the magic effect or makes the hype train run for these large language models.
When even me, or maybe even most of the audience, when we think about large language models or chat gpt or any other AI related products, I think what would come to our mind first, I think, would be obviously customer service and creating content. But then you spoke about how it would help travel team and quality assurance team. So that was very interesting and yeah, insightful to hear. Apart from this, data has been everywhere. It's all over the news, and everyone talks about data security and the ethical framework behind data collection. So data is always a talking point for many companies and even for the general public. So why do you think data has become invaluable in the last few years?
Yeah, so that's a good question. The fundamental of these large language models, as we discussed before, is its training data set. I mean, it's only as good as the data with which it's trained on. It doesn't know anything beyond that training data and what it's going to learn in the long run usage of these models. So, that being said, obviously, data sets can be considered as a new gold. I mean, we've always known about the importance of data, like in social media and all of that, but this is much more refined. Like if you take an enterprise, there can be a huge volume of data. I would say pretty much every enterprise does have data. And also the data sets with which the models are being trained makes it more capable, right? So if you take GPT-3, which is from OpenAI, I believe it is trained on, I guess, like 1.5 billion parameters or like 150 billion parameters, if I'm not wrong. But the point is, GPT-4, the next version, is trained on 1 trillion parameters. So you can see the data set used for training these models are exponentially growing, which means the strength and capabilities of these models are also exponentially growing. And that reminds me of something interesting. So if you take enterprises, they have a huge volume of data. I mean, most of them consider the data to be redundant, like your event logs or other logs and other type of audits and information that you have. Enterprises also use hundreds of different applications for various capabilities like service management or operations management, monitoring, identity and access management. Now the point is, all these systems have, pretty much all of them have their own dedicated audit areas or log management or log collection areas and all of it. And all these years, enterprises looked at these data as something that needs to be archived or redundant and something they keep mainly for compliance or auditing purposes. Otherwise nobody would even look at these data. But with the rise of these large language models, enterprises could actually use these archived data or like old data or whatever they have in their infrastructure, use it to train these large language models and get like valuable insights out of it. So what was considered to be obsolete just a few months back Today it can prove to be very valuable, just as long as you know how to use this data and train your own large language models. And these models doesn't have to be services offered by any vendor specifically. There are a lot of open source large language models that you could download and deploy in your own premises, in your own infrastructure, and train it with your own data. So that way you can get the best out of your data that you have in your own enterprise organization.
Sure. Also, zero trust architecture has also been gaining popularity, as we all know. So, how does it help with data security?
So zero trust is it's a principle as a part of cybersecurity. Now, with the rise of these large language models, there are some data security and data privacy concerns that have come up around these usage of these large language models. So we've seen instances where such models have been used for creating malicious content or even malwares, to be precise. And these malwares are quite efficient because they can quite easily circumvent or bypass traditional EDR systems or heuristic systems in place. And then I mean, if you look at like traditional cyber threats, you have phishing. We've all read phishing emails and short messages sent by scammers and all of it. And you know how it is, right? So generally it'll have a lot of typos or grammatical errors, and it's quite easy for general public to differentiate a phishing email from a genuine email. But imagine these models writing those phishing emails. So if somebody were to take a hold of one of these LLMs and use it for like creating phishing emails or preparing for a social engineering attack. I mean, we all have our social media platform. Our information is there in many areas of the World Wide Web. So it's quite easy for these models to be used for such malicious purposes like social engineering attacks or in creating malwares.
Yes, it
So
would be too perfect to identify them.
exactly, even a tech savvy person would probably fall for a phishing email, so long as it well thought out and well written. A phishing email from large language model can do a huge damage when compared to traditional phishing emails
Yes,
that either
exactly.
automatically goes to your spam folder or something that you read and immediately identify like, no, this is not real, right? So in those areas, obviously when you have a powerful tool, it could be used for any purpose, and you will always have folks using it for such malicious purposes. And that's where zero trust comes in handy, because if you have a social engineering attack, or let's say you have an insider threat, the biggest pointer that these cyber threats focuses on is standing privileges. Standing privileges is where you provided access to somebody and the access stays forever, today, tomorrow, the day after, and every single day the person comes, and obviously they need access to do their day-to-day operations, which we understand. But the point is, in order for them to perform their day-to-day operations, if you give them administrative access, a standing administrative access that works forever, that is going to be a problem. And zero trust is a principle that basically instructs and helps enterprises in avoiding such standing privileges. So if somebody needs access at a particular point of time, you have to have a zero trust system in place which can compute the necessity or the requirement in real time, provide the required access, just enough access for them to do their tasks and day-to-day operations, and then revoke access immediately. So I mean, to put it simple, zero trust basically means you verify everything. And to verify that, it's obviously not something that you can do manually, verify everything. But zero trust, there are systems in place. Even in Manage Engine, we have solutions that leverage this zero trust beautifully. It takes hundreds of parameters and factors them in and checks the posture of the users, the device, and all of it, and then comes up with a risk assessment score. And based on that, it will provide conditional access as and when it's required.
Yes. When I think about and when I read about zero trust, a slogan comes to my mind. It says, never trust, always verify, right?
Yeah, I mean, from a fundamental look at it,
Yes.
zero trust might like sound like a oxymoron, right? So it says zero, and then
Yeah,
it
and it
says
says
trust.
trust.
So is it zero or is it trust? So it sounds like that, but I mean, the principle of it is like you said, it's about verifying. And if you take any enterprise, there are only five core components that comprises an enterprise IT environment. The first is users. So you have internal users, external users, vendors, third-party consultants, and all of it. And then you have devices, company provided devices like your laptop or mobile phones, or some companies, follow the BYOD model where you can bring your own device, hook up to the network, and leverage it. Different type of devices. And then third component is your network. So you have your own internal network or a SD-WAN network or an external network or a public facing network, and so many of them could be there. The fourth is applications. So you probably have in-house applications or externally procured applications from hundreds of different vendors for hundreds of different purposes. That would definitely be there in enterprises. And finally, you have data. There are different types of data, and some of these data probably resides inside those applications or in databases or in so many places. So to recap, you have users, devices, network, application, and data. And if you look at any enterprise IT, these are the five components that comprises it. I mean, if you pick anything, it will fall into the bucket, into one of these five categories. And zero trust is all about taking these five components and coming up with a real-time assessment of the posture. So is the network secure? Is the person accessing the internal network from a secure network? Is their device secure? Does it have an anti-malware solution or an antivirus solution working properly? And the application, like, is this application really required for this person based on their identity and role? And finally, the data. So when we do give access to an application or a critical infrastructure or a device, you think about how much access the user should be provided in terms of accessing the data inside it. So that's basically what it all boils down to.
If we start talking about cybersecurity risks, I think we can go on and on about cybersecurity because there are so many out there. And I recently read a news and I wanted to share it with you. So a man from northern part of China, if I'm not wrong, he was scammed of 4.3 million yuan, which is close to 6 million US dollars. And the scammer had used an AI powered face swapping technology to impersonate the victim's close friend to get the money. So these incidents are very disturbing, and if I was in his place, I think even I would have done the same. So can you talk to us about the cybersecurity risks, and especially how LLMs play a role, and how we can? Is there any way that we could use LLMs for cybersecurity?
Yes. So because of the way or the nature of these large language models, I mean, we talked about it earlier. We touched upon a little bit about the threats like malicious content creation, malwares, and all of it. And because they are very good in, image generation, it can obviously be used for.
Before we go deep into that, I have another doubt. Does any of these tools like ChatGPT or Dali or any other large language model, do they have any security risks, or are they completely safe?
Yeah, it's difficult to say it's completely safe. Obviously, as I mentioned earlier, these models are still in evolution. So we had ChatGPT 3, and now we have GPT 4, and probably down the line somewhere in the future there will be GPT 5 and all of it. But yeah, so one of the challenges with these models is the inherent vulnerabilities and bugs that are fundamentally there within these models. So it's I mean, in general, in software development, we generally say like there is no products that is 100% bug free or vulnerability free. We constantly look out for it. It's always a cat and mouse chase, and the same goes for LLMs as well. But the problem is that because these models are so capable and powerful, even a small vulnerability or a crack in the door could potentially have serious consequences. So imagine a hacker group or a malicious organization gets a hold of these vulnerabilities or open bugs identified in these models. They could be able to exploit it and get to sensitive data, or even disrupt serious infrastructure applications and cause damages. So in that sense, a caution is required on how you use these, which models you use. Are you using it as a service, or are you using it as a custom in-house model that you deploy on your own, and train it on your own and make use of it on a day-to-day basis? So the exposure can be limited by being intelligent and be cautious in what you choose and where you deploy and how you deploy it. But that being said, General customers or general audience, people who use these models, they don't have any sensitive data to share in the first place. But we have seen instances where even large enterprises have accidentally shared their internal process documents or some sensitive information to these large language model services, to improve it or gain. I mean, it's quite natural for them to, get the more help of these models to improve or perform their tasks efficiently.
Maybe someone could input
Yeah.
a very important document,
Exactly.
sensitive data could be there.
It has happened before, and we have read about it in the news. Even large enterprises and organizations have fallen for these accidents. I would call it as accidents. But yeah, I mean, we need to ensure that enterprises need to ensure that their users are well informed about the models. And I would think that enterprises should come up with a policy. Like, if you think about social media, there was a time where social media was relatively new, and enterprises had no clue of what to do about it. Obviously, the users and the employees and staff in the organizations would use these social medias. I mean, so at some point, every organization worked on a social media policy, and now it's well defined and well informed. It's the same needs to be done for large language models, or as such organizations should come up with a policy on the usage of these large language models. In some areas it is okay to use, I would say, but there are so many areas where it's absolutely not okay to use these models, especially ones that are offered by third party vendors and you procure it as a service and make use of it. In those cases, you have to be very conscious and very precise about what is allowed and what is not allowed, and that needs to be communicated to your staff. And also, you have to have a policy that is well defined. So I would say it's going to be part of organizational policy. So one such policy will be the usage of these generative AI and large language models.
Yes, and I recently read a statistic about how employees don't tell their employers, obviously, because now, because it's a very emerging technology, no one has any policy drafted for their employees as such. So employees without the knowledge of their boss or their employees, they started using open source to draft documents, to draft emails. So that's a growing concern. It's important, I think, for employers, major organizations, even small enterprises, to have a look at this and just not overlook on the security risks of large language models. Um, so moving on from this, and Ganesh Chellappa, audience should know, is an expert on privilege access management. So I am sure audience would like to know a lot more about privilege access management. But since we have only a little bit of time, can you just tell us how you can how privilege access management can be optimized effectively?
Sure. So we talked about cyber threats, and we mentioned a few important points like phishing or malwares or social engineering attack or insider threats and all of it. The fundamental of a privilege access management solution is to reduce the attack surface in any infrastructure. So if you take typical organizations, they would have hundreds or probably thousands of privilege accounts. Virtual machines or servers or endpoints or even applications all come with a pre-defined administrative account. So it's impossible for you to have a device without a privileged account, right? So you may not have access to it, but there is one such account that is quite powerful. I mean, if you log in with that account, be it a server or a device, you could do pretty powerful actions in those devices. So if you have these accounts in huge volumes, and if it's unaccounted for and it's uncontrollably shared with so many people, that's when you have a problem. It's very easy for one of these highly privileged accounts to be compromised or accidentally shared or exposed to the general public, and that could basically disrupt your entire organization. So the fundamental task of a privilege access management is to typically reduce the attack surface by reducing the number of such privilege accounts. So it will essentially help you in cleaning up how many such accounts are there. The next option would be to control the privileges. Say today you have 25 members who are part of your domain admin group. They are all domain admins, and if one of their account gets compromised, your entire domain is compromised. So PAM solutions generally allow you to remove such users from being part of domain admin group or a local admin group, or having full on admin access. Instead, these systems act as a proxy to provide privilege access just when it's required, as and when it's required. So if a user needs to go to the firewall tomorrow from 9 a.m. to 10 a.m., that's exact time for which the user will get access, and there'll be full audit and the incident details of why this user need access. And tomorrow when they do connect to the firewall and do whatever changes they want to do, these systems can record all the activities they performed in those particular privilege sessions. And that's fundamentally what makes privilege access management powerful. And because it controls privilege access and also records all the activities that are happening in your entire IT infrastructure, it can also be used in the context of large language models by using this data to be analyzed by an AI engine. So even in Manage Engine, we have our own deep learning engine named Zia. It's quite powerful, and the idea is to crunch these raw audits and activities that are like happening in real time, process it, not only for like anomaly detection or threat detection. Obviously we can detect a threat if somebody does something that they are not authorized to do. These systems can detect it, a lot of systems can detect it, but the point is to remediate the threat. So if somebody is trying to delete a sensitive application, for example, the system should not only detect it and remind or alert the administrators to say like, oops, this person is doing something they're not authorized to do, but block the user from doing that malicious activity. From what I hear, as a common concern with the customers and prospects and the industry decision makers that I talk to, they always say that they have too much of alerts and too much of notifications about these activities, and 99% of them are false positives. That's the pain point they tell me. Now the problem is, because there are so much of false positive, it's easy for you to ignore 1% or one of the 1% valid malicious activity. It can go overlooked and it can cause a serious
Yeah,
impact on
people
your.
would just ignore it,
Exactly.
thinking it's just.
Yeah, I mean, from all day morning I'm looking at the logs and I see everything is false positive, I'm like ignoring, and in between there's one important log where somebody is
Yeah,
really.
they would just ignore that as well.
Exactly. So in that context, PAM solutions can automate threat detection and also remediate by controlling access or terminating access when somebody tries to do something that they are not authorized to do. So that's fundamentally what privilege access management system is all about. In Manage Engine, we have a PAM solution. It's something we started building 15 years ago because we were in need of it. We were growing in numbers and we needed a secret vault solution that can do auditing, because we had multiple teams. We had a lot of test machines that will be shared between different teams, for testing purposes and also for development purposes. So at one point it was getting hard for us to record this in traditional basic vaults or in spreadsheets and sharing it in like file shares and all of it. So we were in need of a solution, so we started building a solution for ourselves, and that's where our journey began. So what started as a simple secret vault, enterprise secret vault in 2007, has grown into a full-on privilege access management suite now. So it has all the core capabilities and modules required for a PAM solution, like just-in-time elevation capabilities or self-service elevation capabilities or application or command control capabilities, where you decide what application a user is authorized to use and nothing else. So they won't be able to circumvent that app and do anything else other than use just that one app that is designated for them. Or same goes for Linux machines or Unix based systems. You provide them with a set of commands that they are allowed to use. They won't be able to execute any other commands to perform anything else other than what is required for their roles and for their responsibilities.
It's very interesting that you brought in a correlation between PAM and LLM. I think that's really fascinating. And thank you so much for all the insights.
Yep. Thanks for inviting me. It was wonderful talking to you about large language models and enterprise IT. And hopefully, for the audience, this information, they probably find it informative, I believe. And I'm looking forward to coming back again at some point in future.